morning everyone. Today we will discuss the chapter number 1, representation of geographical features. Outline of the chapters are introduction, interpreting contours on the topo sheet, height, shape, index contour, type of slopes, features related to height and elevation of the landscape, conical hill, watershed, ridges, plateau, cliff, waterfall, pass, saddle, col, gap, settlement pattern, conventional signs and symbols, interpretation of an analysis of topo sheets and legends. Let's start from the introductions. Okay, two types of maps are there. One is called the large scale map and one is called the small scale map. All the maps which are there in your atlas are the small scale map, and the survey maps or ordnance survey maps are known as the large scale maps. Now earths having different features are there on the earth, different landscapes are there on the earth, plateaus are there, mountain are there, ridges are there, valleys are there, different elevation or elevated areas are there, maybe flattened one or maybe elevated one. All these features, how all these features are represented on a piece of paper, or by knowing reading that piece of paper we are knowing about all this detail of these relief features. This is one of the important striking point which strike in our mind, the methods which they have used to represent it. We have the weather map, we have the physical map, we have political map, we have thematic maps, we have maps based on different themes. We have. So these all maps are made by the different techniques. They shown the maps on the piece of paper. In the same one, ordnance survey map or the survey maps are shown or made on the piece of paper. Now surveying is considered a part of science, and its basic objectives are based on that different maps, and that is archaeological maps are there, geological maps are there, topographical maps are there, cadastral maps are there, military maps are there, tourist maps are there. Since from the previous past we have used different techniques to make that one maps on the piece of paper. In that techniques we have Hirsching. First technique is the Hirsching method. What they does in this technique, the lines are very short and they are very closer. If the lines, you can see in this that diagram 1.1, lines are that short lines are there, and these short lines are very close. If the short lines are very close, it means the area or that is having a elevated part of that land feature. It means if these dashes are very closer, it means steep slopes are there, and if the dashes are very wider, it means that is a gentle slopes are there. In the same one, second one is regarding that hill shading. Now in hill shading, two methods they have adapted. Now in that one, you can see the figure 1.2. One side is shown by a dark shade and one side is shown by the light shade. Now what is about this dark shade? What this represent that area, and what the area is represented by this light shade. Now the dark shade represent the steep slopes of that area or slip slope of that land area, and this light shadow show that gentle slope. Okay, next the light is imagined to be vertical over the area being mapped. It means the steep slopes are then shown by the dark shading and the level grounds, while the light is imagined to be shining from the south. It means it shows that the southeast corners they are getting the light, and northwest area is there under that shadow. So by this one they represent the topographical map. Now in both the method, maybe Hirsching method or maybe hill shading method, one major problem is that these methods are not able to represent the correct elevation of the height. It means height or the elevation they do not able to represent. Plus also they cover the maximum area. Both the methods cover the maximum area, maximum page area, and it is very difficult to show the rest of the areas. Now third one is the form lines. Now form lines are also known as the contour lines, in which that dashes are shown. This form lines shown by the dashes, and these are almost the approx height. So this form line shows the approx height of the relief features. Now spot height, you can see this 1.4 figure, spot heights are given. on the topographical sheet or on the survey sheet, same sequence, in the same sequence, like these samples are there, in the same sequence they shown the spot height. Now this spot height, spot 240, spot 300, for example spot 400, for example spot 270. On this it shows that on the topographical map, if you are looking that on the topographical map, it shows that certain areas height above the sea level, certain points, certain exact areas height above the sea level is shown by this. Now fifth one is the triangulation method. Now in triangulation method, in this method, height of the place is fixed using the trigonometrical method is shown with the triangle. And on the topo sheet, when you I will show you in rest of the slides regarding the topo sheet. So in that topo sheet, same pattern they have shown, like triangle 340, like triangle 300. That's same in shown in the topo sheet also. Next one, fifth one is the benchmark. Now what is benchmark? In few areas where where there is required to make the benchmark, for representing the relief features height. So this benchmark is made on that area, or symbol or of that rocks or symbol or something is made on that area, and they write on that BM, for example benchmark 200. It means that area or that certain point is having 200 meter above the sea level. So benchmark are the permanent survey point. These are the permanent survey points are there, shown by a stone or a building. They indicate a height of that point above the sea level. It means if you are on the topo sheet, if you are looking somewhere is written BM 200, BM 300, BM 246, like that, it means that certain areas spot height is 200 or that for example above the sea level, and it is permanent surveyed. These are permanently surveyed. Now heading toward the our next topic, and that is interpretation contours on the topo sheet height and shape. Now when the contour concept came, it solved our biggest problem, and that is regarding about the height above the sea level. These contours are the solution for that all the methods, and by these contours we are knowing the exact height above the sea level of different physical features. Maybe it's a plain table, or maybe it's a conical mountain or ridges or something else. Okay, so the topographical maps are a composition of visible landscape comprising both physical features like including relief, drainage, vegetation, or man-made features like settlements, triangulated height, road, canals. It means on the topo sheet, when you look toward the topo sheet contain all the details that is required for analyzing that area. Okay, you will get the area, you will get that one particular area's sheet number, sheet name. You will get inside the topo sheet, you will get all the details regarding the physical features and all the features which are made by the human being or by the human construction. Everything you can see on the topographical maps. Now if we look toward the definition, in the short definition we can say a contour line is an imaginary line joining on the places which are at the same height above the sea level. Now why is it imaginary line? Because these lines are not permanently made on the ground. There is no line are made on the ground. These are the imaginary lines which are shown on the topo sheet. Why? Because these lines can solve our problem regarding the height. So these lines are made if the places are having the same equal height above the sea level, and that is contours. Like next one is the index contour. Now ordnance survey maps of 1:50,000 scale have contours drawn at an interval of 20 meters. 1 centimeter on the map, 1 centimeter on the map is equivalent to 50,000 centimeter on the ground, and according to this scale contour interval is of 20 meter, and everything is written on the bottom of the topographical sheet. So every fifth line will be 100, every fifth line will be of 100 meters. Now next for contouring. Now slope and land is determined by the spacing of contour. Now spacing of contour, how this spacing of contour shows that steep slopes or the gentle slopes. See that one figure 1.7, you can see this in figure 1.7. 1.7. These lines are very closer to each other. It means this area will have the steep slope, and these lines are wider from each other. It means a lot of gap is there, space is there. It means that features this side, the left hand side of this feature will have the gentle slope. So if the contour lines are closer, there is a steep slope is there. If the contour lines are wider or the space is more, it means that area will is having a gentle slopes. Now next one is the related features related to the height and elevation of landscapes. Now you can see 1.9a, a conical hill is there. In this one almost the gap is same. You can see almost the gap around this inside the contour lines are almost same. That's why this contour line represent the conical peak. Now this line which is meter is written over here, this line represent the cross section of a conical hill. Now conical hill is showing by close contour, almost circular in shape, and the space between contours are uniform. It means there is a uniformity between all the contour which are represented over here, like that 100, 200, 300, 400, 500, 600, and see the gap is almost equal. So it shows, it resemble, it makes that on that surface area there is a conical peak, and this is the feature which is shown on 1.9b, a conical peak. This is the real picture of conical peak, and this is the contour representation and the cross section of the conical peak. Now next one is the gentle and steep slopes are shown on the 1.10. See that one, contours are very closer, this shows the steep slope. Contours are very wider, this shows the gentle slope. And here 1.10b, a gentle slope is shown, and here 1.10c, a steep slope. You can compare both the pictures. This is a picture of gentle slope, and this is picture of a steep slope. You can compare both the picture, how much difference is there, and this contour shows the difference. This contour which is shown here, this shows the difference. One side the contours are very closer, and one side the contours are very wider. So in this way we can know regarding the slopes or spacing. Now about the ridges. Now definition of a ridge is a mountain. A ridge is a mountain of a geographical feature consisting of chain of mountains. Now a ridge, it means many mountains are connected to each other and that form the ridges. In that next one is the watershed ridge. Now watershed ridge, it means the water is divided in different direction because of the ridges. That's why it is called a watershed ridge. Represent a hill ridge rising 100 meter. On the west the hill rises about 60 meter in the distance AB, but on the east the ridge of the land rises 60 meter in the longer distance DE. So you can see that here contours are very closer. Here the contours are very closer, and here the contours are having a large space. Okay, so in this way we can know that if the water is going to spread off from this area, it will divide it into the direction of the gentle slope, from steep slope toward the gentle slope. Okay, next one, representation of the relief by contours, plateau. Okay, so first example is the plateau. Now how the plateaus are represented? Now plateau is a tableland. You heard about that in junior class also. Plateau is a tableland. You can see this tableland. Plateau is a tableland which is almost rises from the of same height, rises from all the direction, and that is plateau. Here the physical feature is there. Plateau of picture is given over here, and here the contour lines with the cross section is given here. See both the side contour lines are of the same gap. All the contour lines are having the same gap. You can see both the side. See this side and see this side. Both the side the contour lines are having the same gap, and middle of that area is having a wider gap. It shows that middle of the area is having a tableland, and this tableland represents a plateau, a complete plateau. So this is 1.13b, you can see the picture, and 1.13a you can see the cross section of a contour line. This is known as the cross section. This is known as the cross section. This one is known as the cross section. You can see toward this is the cross section of a contour. Okay, next one, a cliff. Now if you have seen coastal areas, in some coastal areas, this features are made. This feature, you can see this feature is made by the physically. So this is known as a cliff. It means that a elevated part of land which rises above the sea level near to the coast, elevated part which rises above the sea level is known as the cliff. So this is the cross section of a cliff. You can see the cross section, see minutely this cross section. Contours are having a same gap over here, but all the contours are merging at the same point. See the remarkable difference. These all contour lines are merging on the same contour line, and because of that one, see on that bottom of that one, this cross section, this figure shows this sea is there and this is cliff. This is cliff. The rises stable land near to that area. Okay, now next one is the waterfall. When we go toward the waterfall, it elevated part, one elevated part from above the sea level, from where the water is falling off from a great height. A waterfall is a form when there is a sudden fall of water over a steep slopes. Okay, waterfall almost created over those areas where the slopes are steep. You can't create over the gentle areas. Waterfall always created on the steep floors, never on the gentle areas. Now you can see this cross section. You can see the cross section. This cross section. See this cross section. In this cross section, all the points are meeting. Towards almost toward this over here, and over here. It means almost, see bottom of that one fall is there. It means that that elevated part is there, or from this area what is falling from a height and at last reaching toward the lower land areas. It shows the waterfall. Now next one is the a pass, saddle, col and gap. Okay, a pass is formed between the two hills. A gap, a dry gap. A gap can be a dry or gap can be a wet. It means it might be possible between two mountains a dry gap is there, or it might be possible between two mountains a river is flowing. It means if a river is there, it will known as the wet gap. If blank is there, it means a plain surface is there, or it means nothing is there, and then it means there is a dry gap. So a pass is formed between the two hills or mountain and serve a land routes across the mountain ranges. Now a col is formed between the ridges of a watershed. Note in the figure, you will see in the figure, the drop in the height between the two hills in a watershed is known as the col, and a saddle is a shallow depression between two peaks. A gap is low depression close toward the ground and between the ranges of hills. Now see, this is the cross section. You can see the cross section. This is a cross section of a pass, saddle or col or gap. You can see the pass is there, you can see saddle is there, you can see the contours are there, cross section is there. So this feature is shown on this picture. You can see the picture. This is the real picture and this is the cross section of that picture or cross section of the relief feature. In this one, contours are having same gap in one side, another side again same gap, but they are interconnected to each other from the outer side. They are connected to each other from outer side, but inner side they are separated. These contours are separated and those contours are separated, but from the outer side they are connected to each other. So it shows that it is a pass, it is a gap or is a col. So you can see in this same sequence, you can see is that feature of a gap. Two mountains are there, gap is there, two mountains are there, pass is there, two mountains are there, col is there. So this is a feature of a pass, this is a feature of a gap, and this is the feature of a col. In all this feature, one thing is common regarding, that is a contours. Now contours and the cross section made the col, contour and cross section made the passes, contour and cross section made that gap. It means without cross section you can't make the feature on the piece of paper. Without cross section you can't understand the height of the relief feature over that area of physical features, that presentation. Now next one is the type of settlements or settlement pattern. Now human activities, those activities which are done by human, we construct the roads, we construct the railway station, we construct the dak bungalow, post office, different constructions are there, different construction. schools are there, dispensaries are there, hospitals are there, settlements are there, different constructions are there. Now how the different constructions are shown, or how the construction of settlements are shown, how the settlement patterns are shown, how the settlement which are there on the realistic ground, how they are shown on the map. So first pattern is known as the nucleated settlement. Now in nucleated settlement, first of all they are shown by the red color. They are permanent, they are in cluster, they might have the post office, hospital, school, temple and mosque. It means these important feature. If a nucleated settlement is there, it means that area is covering almost many important features regarding that area. Now that area will be more developed in comparison to the other area. Simple is there, if the settlement is nucleated, it shows that the settlement contain almost all facilities. That's why peoples are going to settle over those area in excess. Why the peoples are not going to settle over the deserts area, toward the mountain areas? Because those settlements are not nucleated and permanent. So where the nucleated settlements are there, where the permanent settlements are there, in those area almost all the facilities are provided. Now in linear settlements, you can see in linear settlements are generally made near to the corners, sides of the road, like over the tri-junctions, or junction points of the roads, or sides of the road, like shown in this diagram or feature. You can see this is a linear settlement is there. This shows the linear settlement. This one, this shows the linear settlement. You can see that this shows the linear settlement. Settlements are, you can see settlements are closer toward the road, both the side, or one side or both the side. You can see in this nucleated settlement, settlements are quite closer to each other in a patch, and both the settlements are shown by the red color. Now this, see the third settlement. This settlement is shown by red color, but this settlements can be a permanent or can be temporary, and this settlement generally made over those areas where they have areas lack in facility, or where the areas are too harsh, like in deserts area. It is quite difficult to make the closer settlement in desert area, and it is quite difficult to make the closer settlement in mountain area. In both the conditions, settlement will be isolated from each other. They are having a different settled in different area, so that isolated part is shown in this one. Now it's a feature of nucleated settlement. You can see this is the feature of a nucleated settlement. It's a patchwork from the topo sheet. This is the settlement of that one, linear settlement, and this one shows the scattered settlement. So these all three settlements shows the different patterns. Now this is your topo sheet. Okay, vertical red line and this horizontal red line. Okay, this vertical red line shows the easting. This horizontal red line, like 73, 74, 75, 76, 77, 78 and so on till 83. This all horizontal lines are shown the northing, and this all 91 till that 99 and 100 and next one, it shows the easting. So this easting and northing is very important when we have to calculate the 6-figure that grid reference or the 4-figure grid reference. Later on in class 10th you will do that, 6-figure grid reference or 4-figure grid reference. Now this the settlements are shown over here. These all are the settlement. This black line, can you see this black line? This black line shows the, see that, this all black line. This black line shows the drainage pattern. This all black line near to this one, these are shown the drainage pattern. This all black line. Now this closer to the river, this cracks and black line shows the riverine areas or badlands, and this patch of land on the riverbed is shown as the river island. Now these are the contours. You can see these are the contour lines which we have discussed right now. These are the contour lines are there. This blue color, can you see this blue color on the bed of river? It shows the water. This red color, red line, thick red line shows the metal road. This black line with the crack shows the railway line with the railway station. Here you can see two mountain ridges are there along with the gap ridges are there. Here the agricultural lands are shown by the red color. This that patch of this area shown the desert. This shown the river areas. Okay, now next one. Above over here you will have that one sheet number, sheet name, like 45D7 or 45D10. You will get the details of the sheet. Then here it is written 1:50,000. Generally in class, when you are in class 10th, question will be arises on this details or legends or this outer details or marginal information. They ask you about the RF representative fraction is 1 centimeter on the map is equivalent to 50,000 centimeter on the ground. It means this 1 centimeter on the map will show the 50,000 centimeter on the ground. So statement over here, statement is also written there, 2 centimeter is equal to 1 kilometer. It means ki when you convert this RF into statement, when you will convert this RF into this statement will be 2 centimeter is equal to 1 kilometer. It means 2 centimeter on this map, anywhere 2 centimeter or 2 centimeter on the map will represent the 1 kilometer on the ground. Okay, it shows the 1 kilometer on the ground. Now next one is the over here, that contour interval also written there, 20 meters, and this is your topographical sheet number 45D7. Okay, main sheet is of 45, 46, 47, 48. You will have that sheet division, so it will divide it into the D and then divided into 7. So 45D7 or 45D10 is in your syllabus in class 10th. Next one, see the interpretation of the analysis of the given topo sheet 45D7. For example, you can have the 45D7 or you can have the 45D10, it doesn't matter, but the things are, for example, with reference to the survey map you will have the sheet number like 45D7. With reference to the survey map you have the scale 1:50,000, which is equivalent to, when converted into the statement, it is equivalent to 2 centimeters equal to 1 kilometer. Your sheet number, your area, maybe of Gujarat, maybe of Rajasthan, maybe of Madhya Pradesh, maybe of Uttarakhand, maybe of UP, area will be given on top of that sheet. Now what the main features are there? First feature, height and contour are given in meters. Every height which is any elevated area, every elevated area will give that measurement is given into the meter. Then contour interval will be 20 meter and it is fixed. Contours are imaginary lines, hence the approximate. Now water feature are shown by the blue color. Now cultivated areas are shown by the yellow color. Uncultivated areas are shown by the white color. Okay, next exterior of boundaries are shown by the different, that one of forest or different by the marks. Okay, 8R represent the relative height of, or relative depth, or it depend on the where the 8R is written or where the 10R for example are written. Woody areas are shown by the green color. Okay, relative height are shown by that one 30R near to the tank or that one well or etc. Now distance stone is that is also known as a milestone. Symbols are given near to the road. Different conventional symbols and different conventional signs are used on topographical map, and it is quite very easy to know about the relief feature, and it is need of that topo sheet, because if the features correct features will made on that topo sheet, where we will get the space to make the other things. So symbols and conventional symbols and signs are used so that we can reduce the space and so that it is easy and convenient to know regarding the land features. Now next one, tank show dry in area usually contain the water, and usually in July to Feb, and the cultivated time period, then nucleated settlement, then linear settlement, then scattered settlement. It means different settlements and different patterns of settlement. Now in front of you the conventional signs and symbols are and legends are there. By reading, it is must, you have to read this, you have to read this, you have to learn this, you have to understand this all feature. If you are knowing this all feature, it is quite easier you to analysis, to interpret the topo sheet. Otherwise you will not able to understand. If the symbols like this one, if the symbols are that made on that topo sheet and you are not knowing about the symbol, it is very tough to know about the relief feature. It is very tough to know about the feature, maybe natural feature or maybe man-made feature. It means it is quite important and needed. Now suppose post office, suppose I am telling you, suppose post office, this post office, PO is written on the topo sheet and you are not knowing what is PO. Suppose PTO you are not knowing. It means ki you will not able to know about, or PES or something else. If you, it means ki it will be difficult to analyze the topo sheet. Now you have to know regarding that this is your RF 1:50,000. You have this one is called the subdivision and this one is called the division of the scale. Three methods are there to represent the scale. Listen in carefully. Three methods are there by which we can represent the scale. One is called the RF method, representative fraction. One is the linear scale or the graphical scale, and one is this one statement 2 centimeters equal to 1 kilometer. Your RF and settlement, that statement will be almost fixed. This statement shows that 2 centimeter on the map is equivalent to 1 kilometer. This RF shows 1 centimeter on the map is equivalent to 50,000 centimeter on the ground. This statement can be converted into the statement. This RF can be converted into the statement, and this statement can be converted into the RF. It is quite very easy. Now next one is your that technical terms you have to read. What is cartography, scale, contours, rock outcrop, or nucleated or settlement, or nucleated settlement, linear settlement, or scattered settlements, or different. So yeah, and this is one of the summary of the chapter. So you have to read this all summary and this is your original topo sheet. Again, an example is there in front of your topo sheet. In that you can see this blue color. I am going to show you what the blue color. This one. This blue color shows the water body. It's a dam, okay, and here the embankment work is done, and here this is canal. Can you see this one, this line to line? Okay, this is a canal. It means from dam, this agriculture fields is a land, agriculture land is there. This agriculture land is connected, is irrigated by the canal, and canal is direct connected to the dam. Here the settlement patterns are there. Here the name river is there, and name of the river like Sukli Nadi. Here that one plantation is there. Here spot height is there. This is the metal road. Okay, this area this area show the vegetation, green color with the vegetation, and this all brown color shows the contours. This black color shows the boundaries. Okay, this all cracks and black color shows that one drainage pattern. Drainage pattern can be radial, can be trilized, or can be dispersed. Okay, it depend on the feature. The features are shown on that one. We can say that this is known as the nucleated settlement. Lot of facilities are there. Lot of settlements are come very closer. They are pointed on this topo sheet. Again, I am telling you, this is your RF 1:50,000, and this is your statement 2 centimeters equal to 1 kilometer. Now RF can convert into the statement, and a statement can convert into the RF. Now here it is written 20 meter above the sea level. 45D7 or 45D10, whatever the sheet you have, contour interval will be the same one, and this is the original sheet of 45D10 2005 geography. Next, here is your exercise. Read it carefully and try to solve the questions by seeing that that theory part. You will able to solve it. Okay. Next one is your worksheet. Analysis the contours. You analyze the contour and try to make the features on the piece of paper, or you can analyze the contour and you can answer A, what represent A, B, C, D, or E and F. All this that alphabet, what this alphabet, this contour cross section represent what? This is the cross section and what they represent. Please try to solve this. At last, thank you for today's video. We will meet in our next video. Thank you.